Up to this point, we've only looked at series that involve numbers, and we've determined whether or not those series converge or diverge. Now we're going to look at series that also involve a variable, the variable x. Okay, so for some x's, the series is going to converge, and for other x's, the series is going to diverge. So these are series, but they're actually functions of x. All the points x where it converges, we're going to call the interval of convergence, which I abbreviate IOC. So this video is how to find the interval of convergence of a power series. Now again, what's a power series? It's powers of x minus a, so it's x minus a to the n times constants b sub n. All right, now how are we going to figure out what values of x our series converges for? And the answer is we're going to use the ratio test. And remember, with the ratio test, you look at the limit as n tends to infinity of a sub n plus 1 over a sub n. And whenever that's less than 1, then it converges absolutely. So that's what we're going to do. We're going to take the limit as n tends to infinity of a sub n plus 1 over a sub n. We're going to set it equal, or set it less than 1 and solve for x. All right. So the first case we're going to look at is f of x is x minus 3 to the n over 2 to the n running from 0 to infinity. Okay, so the ratio test says I look at a sub n plus 1 over a sub n. That is x minus 3 to the n plus 1 over 2 to the n plus 1. And then if I divide by a sub n, that's the same as taking this and flipping it. So I get 2 to the n over x minus 3 to the n. And now I have to clean that up. Well, n factors of 2 here, n plus 1 factors of 2 here, kicks a 2 downstairs. N plus 1 factors of x minus 3, n factors of x minus 3 leaves an x minus 3 upstairs, and it's still inside the absolute value. So now, this simplifies to that. I want to take the limit as n tends to infinity. Well, you don't see an n there, so the limit is just that. So what I get is 1/2 absolute value of x minus 3 less than 1, which by the way is the same as what? Absolute value of x minus 3 less than 2. So that says x minus 3 is between 2 and minus 2. Now if I add 3 to everything, I get x is between 1 and 5. That's almost my interval of convergence. Now I have to check what happens at 1, and I have to check what happens at 5. If my series diverges at 1, then I do not include it in my interval of convergence. If my series converges, then I do include it in my interval of convergence. That's simple. All right, so let's test x equals 1. Well, I go back up here and I stick in 1. And when I do that, I get what? 1 minus 3? Well, 1 minus 3 is what? Minus 2. So upstairs I get minus 2 to the n. Downstairs I get 2 to the n. It's not hard to figure out that that simplifies to just minus 1 to the n. So I've got the series n running from 0 to infinity of minus 1 to the n. Well, you know what? That is a geometric series, if you think about it, r to the n. It's a geometric series with r being minus 1. Well, do you remember geometric series only converge if the absolute value of r is less than 1? Well, the absolute value of r is not less than 1, so the series diverges. All right, now when we plug in x equals 5, we get what? 5 minus 3, that's 2. So you get 2 to the n over 2 to the n. The top is 2 to the n, the bottom is 2 to the n. And so 2 to the n over 2 to the n is just n running from 0 to infinity of 1 to the n. Guess what? That is just a geometric series with r being 1. And again, a geometric series only converges when the absolute value of r is less than 1. Not the case here. Therefore, it does what? Diverges. All right, so what is our interval of convergence? The answer is it is the interval from 1 to 5. That's what we had up here. But checking the endpoints says we do not include the endpoints. All right, now what is radius of convergence? Well, the radius of convergence is half the length of the interval of convergence. Okay, so what's the length of this interval? Well, it's the larger endpoint subtract the smaller. That's the length of the interval. So what's the radius of convergence? It's 1/2 5 subtract 1, or 1/2 4, or 2. That's the radius of convergence. All right, let's look at our next example. Summation n running from 0 to infinity of x minus 1 to the n over 2 to the n. Again, we're going to run the ratio test on it, which says what? We're going to look at a sub n plus 1 over a sub n. Well, a sub n plus 1 is this. Divided by a sub n means I just take this and flip it. And then if I clean things up, I just get this. Again, I do not have an n there anywhere. So it's 1/2 absolute value of x minus 1 less than 1. I multiply everything by 2. I get the absolute value of x minus 1 less than 2. I translate that to an inequality. X minus 1 has to be between 2 and minus 2. I add 1 to everything. X has to be between minus 1 and 3. That's almost my interval of convergence. I just have to check the endpoints. So let's check the endpoints. When x is minus 1, I stick in a minus 1 here. I get minus 1 to the n over 2 to the n. That gives me a minus 2 to the n over 2 to the n. That gives me a minus 2 over 2 all to the n, or a minus 1 to the n. And again, like I said before, that is a geometric series. R is minus 1. And I'm telling you that that diverges because the absolute value of r is not strictly less than 1. Another way to look at it is this. Any series that converges, the limit of the nth term has to be 0. But the limit of the nth term here is not 0. It's just alternates between 1 and minus 1. All right. Now let's plug in x equals minus 1. Well, if I stick in x, or rather I just did that, right? Let's stick in x equals what, 3? Okay, so let's stick in x equals 3. When we have x equals 3, I stick 3 in. I get what? 2 to the n over 2 to the n, that series. That's n running from 0 to infinity of 1. Again, that's geometric series. R is equal to 1, if you will. That also does what? Diverges. So I check both endpoints, and both endpoints, it diverges. So what's my interval of convergence? Minus 1 to 3. Do not include either endpoint. What's my radius of convergence? It's half the length of the interval. So there's 1/2, 4 minus a minus 1, or 1/2 times 4, or what, 2. All right, so that's got that one. Let's look at the next example. The next example is the summation in running from 2 to infinity of x plus 4 to the n, right? Again, what do? I do the ratio test. What I end up with this time is n over n plus 1 times the absolute value of x plus 4. Now, when I take the limit as n tends to infinity, I have to figure out what this limit is. Well, by the way, this is just a constant. Doesn't move with n. Okay, so n tends to infinity of this. That's infinity over infinity. Use L'Hopital's rule. What do you get? The absolute value of x minus 4 less than 1. Which says what? Not x minus 4, rather x plus 4. So x plus 4 is stuck between 1 and minus 1. Subtract 4 from everything. X is between minus 3 and minus 5. That's almost our interval of convergence. I just have to figure out what happens at the endpoints. So when x is minus 5, I stick in minus 5 up here. I get what? Minus 5, add 4 to the n, all over n. I get this series, minus 1 to the n over n running from 2 to infinity. Well, what does that do? I claim that that converges, we've seen that before, by the alternating series test. All right, so when x is minus 5, it converges. What does that mean? That means I include minus 5 in my interval of convergence. Now when I check the other endpoint, x equals minus 3, I stick minus 3 in. Minus 3 add 4 is 1. I get summation 2 running from 1, or n running from 2 to infinity of 1 to the n over n, which is just the summation n running from 2 to infinity of 1 over n. And that's our old friend, the harmonic series. P series, p equal 1. What does that do? It diverges. All right, so what's the bottom line? I include minus 5, hence the square bracket. I do not include minus 3, hence the round bracket, and that is my interval of convergence. What's my radius of convergence? It's half the length of the interval, so I take minus 3, subtract a minus 5. That's minus 3, add 5, or 2. 1/2 times 2 is 1. So my radius of convergence in this case is 1.